Welcome back, scholars, to our final installment for Unit 1, where we focus on problem solving and critical thinking. A nice slow immersion into our time together. For today's content, we have one vocabulary word, Polya's four-step problem-solving procedure. And I encourage you to possibly click, the second and third link in your Google search, where you get to learn a little bit more about George Polya and why he is famous, and his research and contributions to not only the mathematical community but our society as well. Our learning objective for today's content includes learning Polya's four-step problem-solving procedure, so I can apply the technique to all decision-making processes in my life. I'll know I've got it when I can explain Polya's four-step problem-solving procedure to a peer. So first and foremost, I'd like for you to take a moment to have a conversation with your peers, virtually and electronically, as to why do we call math problems problems? This idea of a problem, what does it actually constitute? What does it mean? Um, why do we call them problems in society? It has such a negative connotation towards it. Share your thoughts. Let's see what you got to say. The single biggest reason why taking mathematics classes is useful to anyone is that mathematics is all about learning and enhancing problem solving strategies. Okay? Yes, you have to learn how to graph a line, solve a quadratic, and we can start talking about exponentials and logarithms and increase the anxiety. But at its core, mathematics is constantly refining and enhancing your ability to persevere through these problems. And so enter a Hungarian mathematician, George Polya, who did an extensive amount of research on the nature of problem solving. His strategy isn't necessarily earth shattering, it's actually extremely simple. Okay. However, he was kind of the pioneer of this research around problem solving techniques. Okay. So, what does Polya's four-step problem solving procedure look like? Well, first and foremost, you need to understand. Oh, that's unfortunate. The problem. I'll go back and fix that in the coding. Um, So, what does he mean by understanding the problem? Well, the best way to start any problem is to write down information that's provided as you come to it. And remember, we're trying to think broadly here beyond mathematics. Okay, so try and think about maybe something that's coming up in your life. Think back to our first lesson when I asked you about some big decisions that was coming up. Write down the information that you have currently, right? I've been accepted to this university. This is the financial aid that I have, right? Because that in turn is becoming a problem, or I would consider a situation that requires a solution. Especially with longer word problems, if you read the whole thing at once, don't do anything. It's easy to get overwhelmed. Kind of like those big life decisions. If you read the problem simply, or sorry, not simply, slowly and care, come on, work with your mouse. There we go. Writing down information that's provided, you'll always at least have a start on the problem. Another great idea is to carefully identify and write down what it is they're asking you to find. This almost always helps you devise a strategy. There's some R somewhere. There it is. Okay. So first and foremost, deep breath. Read through everything. Consider everything. Make a little bit of a game plan before we get into number two. Design. This is hilarious. Design a plan to solve a problem. New sign would be right. There are many ways to solve problems. Some common strategies include drawing a diagram. That's always a good start. What comes next? Trial and error, creating a list of outcomes, finding or recalling a similar example, and I gotta be using way too many eyes there. Yep. And using arithmetic, algebra, and for geometry. Right? You're like, well, how would geometry necessarily help me with my college or life problem, sir? It wouldn't, right? But we're kind of thinking broadly and considering all angles. Case in point, my friend who owns a landscaping business where he redesigns people's backyards, he uses a considerable amount of geometry. Now, he might not necessarily say he's using the Pythagorean theorem, but when he uses his right angle ruler, guess what? He's using the Pythagorean theorem. Right. So after that, right, after we understand the problem and design a plan to solve the problem, this is usually the most difficult task for many people. You need to carry out your plan to solve the problem. The only way you're going to figure out if like something works is if you do it. So try it out. If it doesn't work, try something else. Be resilient. There are many different ways to attack problems. Oops, put be resilient too soon. And last and not least, and something that we usually take for granted in math class, check your answer. Right? This is Polya's four-step problem-solving procedure. Okay, but you can never underestimate and be too certain regarding huge life decisions. So it's always a good idea to think about whether or not your answer is reasonable. In many cases, you'll be able to use math to check your answer, but when all else fails, use good old-fashioned common sense. Okay? It's a bad idea to make decisions using inductive reasoning or just necessarily your intuition. Um, sure, someone may be able to label you as decisive, but in certain instances, you definitely want to take some time in making decisions. Okay, so over the next couple of slides, you are going to be tasked with solving these application problems. Okay, feel free to use and go about your solution path however you deem fit in this box. I strongly encourage you to work out your solution path on a separate sheet of paper because you might need to draw a diagram. I will include a whiteboard here in case you wanted to also show me what you've worked out on paper. But for the most part, you should be able to type out most of your responses. Okay, so you got about 5 application problems to work your way through. I will highlight here though, right, with this idea of an average. Okay. If you've forgotten what an average, oh, it's the wrong thing. There we go, there's my pen. What an average consists of, right? We would sum the items and divide by the total number of items. Considering this is a senior elective, I want to see if you can recall how to apply this idea of an average. So I'm not going to do too much beyond that, but try your very earnest in attempting to solve this application problem. And some concluding remarks. Word problems tend to cause tension, sweaty palms, upset stomachs. Oop, got a typo here too, etc. To stop that from happening, we're going to call word problems application problems instead. This term is very descriptive of why you should care about solving application problems. It's simply the way you apply skills, knowledge you're acquiring to more than just number crunching or finding what X is. Because let's be honest, when you get out in the real world, X doesn't exist. Okay, you're presented with a scenario, you decide to make a decision, and you got to live with it. Okay, and that's kind of my focus here as your math instructor. And listen, if you stumble across this video on YouTube, sure, I'll be your math instructor too. right? I want you to be able to take the content that we are working our way through and apply it to your immediate um, context so that you can be the best version of yourself and successful. Because remember, the world's an imperfect place and not every problem can be solved. A big part of the problem solving is being able to identify when there is simply no solution. Okay? So keep those things in mind, and we'll have a conversation about this little brain fart there tomorrow after you've made your way through this content during class when we're collaboratively working to make our way through these enhancement opportunities.